Hi, for this recording, I'm going to show you how to solve a differential equation dy dx equal to x squared by y squared over 2x squared. But first of all, we must identify what type of differential equation is this before we solve this equation. We are going to show that the solution is x equal to c times e power 2x over x minus y. First of all, let's examine what type of equation is this. Now recall we have a type equation called a homogeneous equation. If you have f of xy times dx, but g of xy times dy equals 0, and we say that f of xy and g of xy are homogeneous functions of same degree if f of tx, ty is t power n fxy, g of tx, ty is t power n gxy, for some positive integer n, where n is the degree. Now in this particular case, let's look at the equation and rearrange them again. Now our equation is dy dx equal to x squared plus y squared equal to 2x squared. Now you rearrange them, you get x squared times plus y squared multiplied by dx, then plus minus 2x squared times dy is equal to 0. Right? So we have this type of equation. So if you compare with, let's say if you compare fxy, right? You compare with fxy dx plus gxy dy equal to 0. Then we have f of xy is x squared by y squared, and g of xy is minus 2x squared. Now you notice that f of tx ty is tx squared plus ty squared, and then you can pull out a t squared. Then you can do the similar thing for g as well. That means g of, if you change the x to tx and y to ty, right? And then you'll get minus 2 and x change to tx now. And after you do that, you'll find that this is equal to, pull out a t squared, then you have left with minus 2x squared, and this is equal to t squared of gxy. Okay, so this is t squared of gxy, t squared of gxy. Whereas earlier one, this is just t squared of fxy. So we notice that this equation here is a homogeneous equation with degree 2. Alright? So in this case, so this equation is a homogeneous equation of degree 2. Now, when you have a homogeneous equation at degree 2, there is a special way to solve this equation. The method is let y equal to u times x. Okay, let y equal u times x. So if you let y equal u times x, then using the product rule, keep the first term, differentiate second term, keep the second term, differentiate first term, and add them up. And notice that dx is 1. So dy dx become u plus x du dx. Now put this into the original equation. Dy dx over x squared or y squared over 2x squared. In this case, the one on the left hand side is dy dx is equal to u plus x du dx now. And remember that y is equal to u times x there. So whenever you see y, you put y equal to u times x, and that is why you have this y squared become u squared x squared. And then x squared is common, the pull out x squared. So now can we simplify? If you find that x squared is common, it cancel. So you end up with u plus x du dx equal to half of 1 plus u squared. Now I'm going to isolate du dx now. So I minus u on both sides. So half of 1 by u squared minus u. Now I can simplify right hand side again. Now notice that half of 1 plus u squared minus u is half of 1 plus 1 minus 2u plus u squared. And 1 minus 2u by u squared is 1 minus u squared. So the expression is equal to x times du dx equal to 1 minus u squared then divided by 2. Okay, then continue. How do we find the u now? We're going to find out u. The method we're going to find u is called separation of variable. You're going to separate the u and x now. So I'm going to separate u. So on the left hand side, so you have du over 1 minus u squared is equal to dx over half x. Alright, and then right, so after I separate, then I get x on one side, u on one side, so I can integrate both sides now. So integrate both sides. Okay, integration of du over 1 minus u squared plus 1 over 2, 1 over x dx. So integration of 1 over x we know is very easy because integration of 1 over x dx will give you ln absolute value of x plus c. So the right hand side is easy. How about left hand side? The left hand side we're going to do a substitution. What you do is let w, let's say, equal to 1 minus u. Alright, let w equal 1 minus u. Then dw du is minus 1. So du is actually minus dw now. So you change all the u to w. So du equal to minus dw. 1 minus u is w. So 1 minus u squared equal to w squared. So how do you integrate minus 1 over w squared? Now remember, 1 over w squared dw is actually w power minus 2 dw is w power minus 2 plus 1 over minus 2 plus 1. So it's minus w power minus 1 is minus 1 over w. So making use of this, we know how to integrate minus dw over w squared now is equal to negative or negative of this thing. You get w power minus 1 is 1 over w. But w is 1 minus u. Right? So this is actually 1 over 1 minus u. As w is 1 minus u here. Okay, so I can write one more step. You cannot see this. This is 1 over w, right? It's equal to 1 over 1 minus u. So that is why integrating the left hand side, you get integrating the left hand side is equal to 1 over 1 minus u, whereas integrating the right hand side is half ln x now. Now let's continue. We're going to find out what is the expression by putting back u. Now what is u now? Since y equal to u times x, so u is equal to y over x. So the u here is going to be y over x now. So I'm going to simplify this. I multiply the left hand side, every term on the left hand side multiply by x. So multiply by the top, multiply by x, bottom multiply by x. That means I multiply by x here. I'm going to multiply the x on the left hand top and bottom. Alright. So when I multiply by this, I'll get numerator is x, denominator is x minus y. So I have x over x minus y equal to half times ln absolute value of x plus c. Let's continue and simplify. I'm going to move the c to the left hand side. But before I do that, I multiply by 2 first. So bring the 2 over. I should have 2c here, but then 2c is just a fixed number. I just leave it as c now. Then I want to move the c over by subtracting the c both sides now. So I have this blue c here is actually the minus c and shift over. Alright. So now I want to get rid of the ln. So how to get rid of the ln here? So remember the get rid of ln. Right? Remember the how to get rid of ln. If you have say y equal to ln x, what happened? It means the e power y must equal to x, right? You can do this. So you can make use of this kind of situation where the base is e. So it means that e raised to the power 2x over x minus y plus c is equal to ln x now, equal to absolute value of x now. So that means that what I do is actually convert the log form to exponential form, right? Convert the log form to exponential form. So I get rid of the log now. So absolute value of x is equal to e power 2x over x minus y plus c. Now I can break the power up using the power rule. So this is e power 2x over x minus y times e power c. Now e power c is just a number. Means c is a constant here. So I'm going to write e power c as a rate c here. So because absolute value of x equal to rate c times e power 2x over x minus y, so x will be plus or minus rate c times e power 2x x minus y, right? Just remember that if you remember, if you have say absolute value of x equal to 7, then x is what? X will be plus or minus 7, right? So recall this type of thing. So I'm making use of this now. Then I'm going to say, alright, plus or minus c is just a number. So let's call it a capital black C now. So I'm going to call this a capital black C. And eventually, I got an answer. X is equal to, right, c times e power 2x over x minus y as the solution of the differential equation dy dx equal to x squared plus y squared over 2x squared, right? The differential equation, and you have this is the solution. Okay, so that is the end of the solution.